In problem number 3, we've got a random variable x that's got a normal distribution, but we don't know the mean and we don't know the standard deviation. They do tell us that the probability that's less than x is less than 32.83 is equal to 0.834, and they also tell us that the probability that x is greater than or equal to 27.45, that's going to equal 0.409. We're going to use both these pieces of information to write two equations. Whenever they give you a probability, typically what's going to happen, you have to find either the value or the mean or the standard deviation, and you're going to make an equation where the z-score equals the z-score. In this case, we actually have to find both the mean and the standard deviation, so we're going to make two. We're going to convert this to a z-score, and then we're going to convert this 0.834 probability to a z-score. Now we're going to use our calculator, the inverse normal, to do this, keeping in mind that the inverse normal is used when we give it an area to the left or below a value. It's going to give us the value. So in this case, the area to the left of the value we're interested in is 0.834, and we get a z-score of 0.97. Also keep in mind that whenever we're writing z-scores, we round to 3 places. It's actually the only time you're ever going to round in the middle of the problem. Now, I'm going to go ahead and multiply both sides by the standard deviation, and I'm going to get this equation here. Now I'm going to do the same thing for the other piece of information. I'm going to convert this first thing to a z-score by using the formula. And then when I do this other one, you'll notice if it's going to be 0.409 is above my value. Now, the inverse normal finds a value that given an area below it. So if I take that away from 1, I find out the area below it is 0.591. When I enter in 0.591, I find out that the value to the right of that area is going to be 0.23. And again, I'm going to multiply both sides by the standard deviation and get this equation here. Now I'm going to multiply this entire thing by -1, and that's going to change this mu to plus mu. And see, now when I stack these up, you'll notice that if I were to add straight down, the mu's are going to be eliminated. So let's go ahead and do that. When we add this part, we're going to find out we get 5.38. And then on the other side, we're going to get 0.74. And now all I've got to do is divide both sides by 0.74, and we find out that the standard deviation is 7.20, blah, 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 blah. To find the mean, we're going to have to substitute the standard deviation in, and we're not going to use the rounded version. We're going to use the whole number, and we're going to substitute it in, and then all we've got to do is solve for mu, get mu by itself. When you do that, you're going to find that mu is equal to 25.8, and that the standard deviation is equal to 7.27. And that's all there is for that one.